Hello, I'm Paul Beckwoth. I'm at the University of Ottawa. I'm with the Laboratory for Paleoclimatology. Right now, as I'm filming this video, Hurricane Michael is running ashore in the Panhandle in Florida. The origins of this storm are just from a few days ago. This was a tropical storm which then crossed the Gulf of Mexico, and the water in the Gulf of Mexico is incredibly warm. And as you know, if you've watched some of my previous videos on my YouTube channel, Paul Beckwoth, or posted on my website, paulbeckwoth.net, any time that the water temperature is above 26.5 degrees Celsius, then there will be energy coming from the ocean up into the storms. There'll be a lot of evaporation of water and uplift. This warm air will rise up and that water vapor condenses and it fuels these storms. A recent study indicated that for every half a degree Celsius rise in temperature of the sea surface temperature, that leads to an increase in hurricane intensity by about 10 to 15%, just shy of 15%. Anytime for every degree Celsius rise in temperature, there's about 7% more water vapor in the atmosphere, and that water vapor, when you get convective uplift, that water vapor condenses and forms the droplets in clouds, etc., but releases a tremendous amount of energy. So Hurricane Michael is a very, very powerful Category 4. In fact, it reached speeds, I believe, when the eye first touched the shoreline in the Florida Panhandle, the wind speeds were 119 miles an hour. But the storm was moving, as it moved across the coastline, it actually even strengthened. And before the full eye came ashore, which just happened just recently, the wind speeds were 155 miles an hour. Now the cutoff from Category 4 to Category 5 is anything greater than 155 is Category 5. So this storm came ashore at the very top level of Category 4, just a mile per hour under Category 5. And that may be reevaluated by the National Hurricane Center. They may actually classify it as a Category 5, over the next few days. Anyway, this is a horrendous thing for Florida. It's following along the heels of Hurricane Florence. The big problem is that the oceans are just too warm. The oceans have absorbed about 93% of the heat. So when you talk about climate change or global warming, that's only 7% or so of the energy is going into warming the atmosphere. The rest is warming the oceans. And these ocean temperatures are leading, of course, to much more intense storms. But the main purpose of this video is to discuss my initial thoughts on the Intergovernmental Panel on Climate Change 1.5 degrees Celsius report that was just released a few days ago. So this is quite a detailed document, and it's talking about the effects on our planet of 1.5 degrees Celsius, mitigation pathways, can we keep global temperature to 1.5 degrees Celsius. So I'll have some more detailed videos on my thoughts, but this is basically some preliminary thoughts based on what I've read, and I haven't read the full documents yet. I've skimmed them and looked at some of the conclusions for policymakers, etc., but I'm still reading it in detail. But basically a couple things that stand out right away, and the most key thing is, the most important thing from what I see is that the document talks about a temperature baseline in the period from year 1850 to 1900. So if you take the average temperature in that 51-year time span, they're saying that that's the baseline. And they're saying that right now we're 1 degree Celsius above that baseline, and that would lead us 0.5 degrees to reach the 1.5 limit, or a doubling a full degree to reach the 2 degrees Celsius guardrail. Now, there's a big problem with this baseline. Okay, the original IPCC reports, when they first talked about the 2 degrees Celsius guardrail, that wasn't relative to the 1850 to 1900 average. It was relative to the 1750 temperature baseline, basically. And the problem is the difference of temperature from that 1750, the year 1750, pre-industrial revolution, and the 1850 to 1900 average is about 0.3 degrees Celsius. Okay, so that means instead of being at 1 degree above the 1750 number, we're 1.3 degrees above the 1750 number. Now, there's even some controversy in how accurate that 0.3 degrees Celsius number is. And in fact, in the report that was just released, that temperature difference was given as anywhere from 0 to 0.2 degrees Celsius. So I'm not sure really what's going on. I thought the 0.3 number, 0.3 Celsius number was accurate. But even if it was 0.2 degrees, the point is if we can only go up 0.5 degrees to reach the 1.5 limit according to this report, but that number is actually 0.2 or 0.3. If we're already at 1.2 or 1.3, then we have anywhere from 0.2 to 0.3 degrees Celsius to reach the 1.5 limit, not a full 0.5. So this idea of sliding baselines is absurd, and I'm not sure why the issue is being skirted around in the latest report. Another key factor is methane. Okay, the IPCC reports up to now have all indicated that methane isn't going to be a real problem, isn't going to have a large enough effect to warm climate up until the year 2100 or so. That's been the assumption all along, and that comes from computer models, and that's an invalid or erroneous assumption. We see increasing levels of methane coming up from various sources, including the Arctic permafrost, both permafrost on the land thawing out and permafrost on the ocean floor thawing out. We see methane clathrates, which is a form of frozen water surrounding methane molecules in the seafloor and in the ground deep down, where temperatures and pressures are conducive to having this state, and we have the release of that. We're getting torrential rains in various places on the planet, and this is creating marshlands and more wetlands and things, and these are huge emitters of methane. And as I've mentioned in previous videos, it's also very important where the methane is released, because the lifetime of methane is anywhere from 9 to 11 years or so. Methane is broken down mostly by reactions with OH-, which is hydroxide, and the hydroxide is produced from water vapor that is broken down, and that is disassociated, and the levels of OH- vary tremendously with latitude. So there's lots of the hydroxide molecule near the equator, so methane produced at the equator can react and be removed quite quickly, whereas methane up in the Arctic, for example, where it's very dry, there's very little hydroxide, would last a lot longer there. And of course, that's if the methane stayed in those regions. But we know that there's global transport of molecules that are distributed globally. So methane produced at the equator doesn't stay at the equator. A lot of it will move, it will move with the prevailing winds. Same with that's produced up in the Arctic. So that's another factor. I mean, the global warming potential of methane on a 100-year time scale is the number that has been used most frequently in the IPCC reports, and the global warming potential is 34. It used to be, thought to be 20 or 22 or 25 or 24. You see all these different numbers. But the AR5 IPCC report, the most recent one, that 2013 report had it at 34. So one molecule of methane it's actually by weight, I believe, but anyway, the ratio of the methane effect on the warming to the CO2, 34 times over a 100-year time scale. But of course, methane doesn't last that long. Over a 20-year time scale, it's believed 86 is the number, and over a few-year time scale, we're talking northwards of 150 times. So on a weight basis or molecule basis, methane is much more reactive. It absorbs much more. It causes much more warming than CO2 does. So this is a problem because we're doing more and more fracking. Natural gas is methane. So, when the fracking, when you burn methane, it's cleaner burning than coal. But the leak rates of methane are very, very high from natural gas infrastructure, and that negates any positive effect of using methane as opposed to coal. Methane is not a bridge fuel. So methane is pretty much discounted in all of these IPCC reports. Methane and nitrous oxide are mentioned in this one, but not enough. But mostly it's the potential for feedbacks, huge feedbacks that make the climate system very precarious and very unstable and very sensitive to having massive changes. The problem is I have problems with reports that say we have 12 years or 10 years to do something. We're experiencing tremendous consequences of very rapid climate change. I call it abrupt climate change now. Okay, I've been saying for a long time that we're in a global climate emergency, which is as yet undeclared by governments around the world. So in favor of this report, although in the details this report does not go far enough and does not assess the risks, things are worse than this report says. This report is a good step to get much closer to the reality of the abrupt, very rapid climate change that we're seeing. So, and it is getting worldwide press, and it does talk about, there's many people, many scientists, many reports, many governments, they have this mistaken notion that we can just slash fossil fuel emissions and everything will be fine. The problem is that CO2 stays in the atmosphere for tremendously long periods of time. In fact, something like half of it remains after even 1,000 years. So if we were to completely stop the production of CO2, and the lifetime is approaching 1,000 years, it will take a long time for the present CO2 levels to decrease. So slashing emissions is not enough. So we need to, and I've talked about the three-legged bar stool idea for many years, where we need to slash fossil fuel emissions. We need to extract CO2 out of the atmosphere, use carbon dioxide removal or CDR methods to lower carbon dioxide levels in the atmosphere, and we also need to deploy solar radiation management techniques to specifically cool the planet, to buy us time to do these other things, because the danger is as the planet continues to warm, the natural sinks for CO2 and for other greenhouse gases on the planet decrease. They become less effective. They don't absorb as much CO2. So we have a dangerous situation where the CO2 emissions can swamp out the natural sinks. And as the sinks fail, for example, as forests dry out and burn, produce CO2 from the burning as opposed to withdrawing it, then CO2 levels in the atmosphere will skyrocket and go out of human hands, the ability to us to do anything. So we're in a global climate change emergency. the report needs to say that. Thank you.